Hello, my name is Mr. Chunya. Welcome to my study room. Today I'm solving essay question 4 of the 2024 WASSCE Core or General Mathematics paper written by Ghana. And the question has a diagram that is not drawn to scale. And it reads that in the diagram, P, R, Q, and S are points on a circle center O. T is a point outside the circle such that angle RTP equals 20 degrees, angle QSR equals 30 degrees, and the segment PQ is a diameter. Calculate A, angle QRS, B, angle PQS. There are a number of ways we can solve this problem, and I'm going to solve using two different approaches. So let's start with the first approach. And as we always do, you're going to get a key fact from the problem. And one of the most important information in this problem is the fact that the center of the circle is O. And as for the angles, we can see them, so I'll just leave them as they are. But another important information is that PQ is the diameter of the circle. And we start right from there. If PQ is the diameter of the circle, that means that this whole angle here is 90 degrees, right? Someone might ask why. It's because the angle subtended by the diameter of a circle at the circumference of a circle is 90 degrees. So if that is the case, then it also means that this angle here is going to be 60 degrees. Alright. That is not all there is. If this angle here is 60 degrees, then this angle here will also be 60 degrees because the two of them are angles subtended by the same chord PR. And angles subtended by the same chord in the same segment of a circle are equal. So that will also be 60 degrees. By the way, this is QRS, the angle we are solving for, right? Good. Let's continue. PT is a straight line. So if we know angle QSR, which is this, to be 90, it means that this angle here is also 90 degrees. And that is as a result of sum of angles on a straight line or straight angle is 180. So if this side is 90, this side will also be 90. So that means that angle RST will be equal to 30 plus 90, which is the whole of this angle here is 120 degrees. So now taking triangle RST, it means that this angle plus this angle plus the angle we are working should give us 180 degrees, which is the triangle sum theorem, or the sum of angles in the triangle. And then 120 plus 20 is 140. So 140 plus angle QRS equals 180. And that means that angle QRS will be equal to 180 minus 140. And therefore, angle QRS equals 40 degrees. So that is the A part. And then the B part, we are solving for angle PQS, which is here. Now, coming back to triangle QST, when we take this angle here, 90 degrees plus the 20 degrees here plus SQT, that should also give us 180 degrees, which is the triangle sum theorem. So I just added these two to give me 110, and then subtracting 110 from both sides, angle SQT is going to be 180 minus 110, and that equals 70 degrees. And that means this is 70 degrees. So now the whole of this angle here will be straight angle, or the sum of angles on a straight line, and that should be equal to 180. So that means 60 plus angle PQS plus 70 should be equal to 180, and because of angles on a straight line, so angle PQS plus 130 equals 180, and that means that angle PQS will be equal to 180 minus 130, and that equals 50 degrees. So angle QRS is 40 degrees and angle PQS is 50 degrees. And now let me use the second approach, which is also not too difficult. Let's see what we get there. So in the second approach, I'm going to use what we call special angles and segments of circuit theorems to solve this. And they are all circuit theorems, and for each of them, I will quickly state the theorem that brought about that, and then I will use it for what I'm working. We'll just start the same way we started the first one. That because PQ is a diameter, I mean that this is 60 degrees. And because of that, we are going to use a circuit theorem that says that if you have a circle this way, and you have the center of the circle O, then the central angle, let's call it A, which is subtended by an arc, maybe let's call it BC, will be twice the angle B, which is an inscribed angle by the same arc. And another important thing is that if the central angle here is A, the measure of the angle of the arc here will also be A, okay? And B, because I'm talking about relationships, let me write a B word. So B is going to be half A, or half of A, right? Good. Or let me write it outside if possible. So 1/2 of A, that is the angle B here. That is the angle B here. Good. So we're going to use the same idea that this angle here, 90 degrees angle here, is an inscribed angle, or angle subtended at the circumference of the circle. So because of that, the whole of this arc here is going to be twice this angle, which is 180. And that 180 can be broken down. And it makes sense because this is a diameter to the circle, so you divide the circle, which has a total angle of 360 into 2 pi, which is 180. But then the 180 is not even my attention because I want to break it down. So the arc RP is going to be twice of the 60, which is 120 degrees, and then the arc RQ will be twice the 30 degrees, which is 60 degrees. Good. Still give me 180, right? Right. Then now I need this 120 here to be able to find the angle here. Let me call it X. And with that one, the relationship is that if you have a circle and you have a secant cutting through the circle, and you have an angle here, let's call it X, and let's call this angle of this arc here Y, and then let's call the angle in between here Z. Then the angle X will be equal to Y minus Z divided by 2. So I'm going to use this relationship to work out for X. Then I use that. That means that the 20 here, which will represent our X, will be equal to 120, which represent the Y, minus X, which represent the Z, all over 2. And then multiplying both sides by 2, you're going to have 40 equals 120 minus X. I move this to the left side and move this to the right side. I'm going to have x to be equal to 120 minus 40, they both switch side, and x will be equal to 80 degrees. Good. So the arc QS here measures 80 degrees, right? Good. So if we are using the same relationship we had here to work that, then it means that the angle QRS is going to be half of the 80, which is 40 degrees. So by that, then I'll say that the QRS is 40 degrees. And now I'm left with the angle PQS and the total angle around a circle. Oh, the circumference of a circle is 360 degrees, right? Good. So now that I found this circle has 1, 2, 3, 4 arcs, and now I know the angle or measure of 3 of the arcs. So that should be easier for me to find the fourth one, and that will be by adding this. So the arc PS is going to be 360 minus 120 plus 60 plus 80, right? And I think that is 260. So 360 minus 260, we got to 100 degrees. So that means the arc here measures 100 degrees. And you know the arc here, the 100 is supposed to be the central angle. And the angle PQS will be half of the central angle, which is 50 degrees. So that means angle PQS is 50 degrees. And I hope you've learned something new from this, and this is going to help you to solve similar question next time. Don't forget to subscribe to this channel for more videos like this. Till we meet again. Bye bye.